Hi everyone, this is Ashnat Kothari here. So in this particular video, I shall be discussing the indicative solutions for CM2 A for IAI July 2022 session. Before we get started with our discussion regarding the solutions, please make sure that you do like this video if you find it useful. Do drop us any queries you might have through the comment section, and don't forget to subscribe to our channel so that you do not miss out on any sort of content we release over the YouTube channel. Also, I would take this opportunity to inform you all that the batches for IAI December 2022 session at Finatics has started. We would be conducting classes in offline mode, in online mode, as well as in pre-recorded mode. So all our students will be getting access to all these three. Ones who are from Calcutta can attend the offline classes. For the others, they would have option to attend the online classes as well as have access to the entire set of lectures at outset. Along with that, we would be giving extensive set of preparatory resources, which would ensure that a student is going with extremely good preparation, which has delivered tremendous results in the past in form of students securing all India ranks one, or scoring extremely high marks from papers from IFA, or in fact our complete batches for a particular paper achieving 100%. So in case you are looking for the classes, definitely, do reach out to us so that you can start with the preparation as soon as possible. Now, first of all, with respect to overall CM2A paper, in my understanding, this paper was extremely scoring, especially for, students who are well prepared, because a lot of questions are, have been directly taken from, let's say, IFOA past year papers. So ones who have prepared well should be able to, solve those. Apart from that, there was also a high proportion of MCQs in this paper. So this time in CM1, CS1, CS2, the proportion of MCQs were quite less, but for CM2, it was still pretty high, and that makes it even more scoring because the time required is, relatively less for these MCQs. So let's begin with the discussion of the solutions. Question number one. Let me just show you all the answer key for question number one. Part one, 4, part two, 1, part three, 1, part four, 2, part five, 3. I shall also discuss in case I have assumed anything. So like specifically for part two, whenever if we are saying that the securities market are efficient, it means that the price of a security could be seen as nothing but the discounted discounted value of all its cash flows. So in such a case, the NPV shall be nothing but zero over here. Then part four, part five, again, in part 5, there is, I think, one sort of printing error. There is an institution that has bought 1 lakh put options on share X, each of which has a delta of 0.75. So we know that the put option always has a delta which is negative. So what they should mean is rather minus 0.75, and we have worked accordingly. Had you considered 0.75, we would have got a different option. But since we know that put option must have a delta which lies between 0 to minus 1, therefore this should be interpreted as minus 0.75, and thus we would be getting our option as option number 3, that is purchasing 75,000 units of share X. Else if you take 0.75, it would come as option number 2. So it depends how II approaches this. Ideally, I mean, it's an error in the question because it should be minus 0.75. So at least for me, the more logical thing would be that students should be able to identify. But nonetheless, given that it's an error from the from IAI, so therefore students might get marks for option two as well if they work assuming delta of put option to be 0.75 itself. Then we have question two onwards. So this is the answer key: 3, 2, 2, 3, 2. And if there any specific question which I will like to discuss, no, not really. For question three, if any one of you might have the question how it's coming out to be 6.4%. So you have the market price of risk, which is nothing but, let's say, EM minus R by sigma. Market sigma is 0.2 and your EM is 0.6. Using this, you'll get the risk-free rate as nothing but 4%. And now you can use the security market line, which will be nothing but R plus beta I EM minus R. And using this, you'll get the answer as 6.4%. Actually, this was for question 3, part 1 itself. So yeah, I'll come to it as well. For question 3, part 1, it's option 3. For part 2, it's downward sloping as the term increases. So question number part 2, For ones who have prepared, I guess most of must have prepared for CM1 before appearing for CM2. So what they're saying is that a country has a constant real rate and the current rate of inflation are very high. It's expected to decrease in future. So if the inflation rates are expected to decrease in future, therefore the nominal rates of interest are also expected to decrease in future. So the nominal rates of interest are expected to decrease in future. Investors, you can think in this way, the bond investors will prefer to, buy long-term bonds so as to lock in the high interest rates available, which will push the demand high for, long-term bonds, resulting in a lowering of the yield. Remember that the inverse relationship between price and yield. So as the price increases, the yield shall decrease. So this will result into a slope which will be downward sloping. On the y-axis, we have the yields. On the x-axis, we have the duration or term to expiry. Then question number 4, part 1, state the main assumptions under the binomial model for option pricing, fairly bookwork. Part 2, explain the option pricing approach using a stochastic discount factor. Again, fairly bookwork. For part 3, again, there is a one period binomial model. Current price can either be 70, it can go to 100 or 30. The probability of upward movement is 70%, and the strike price is given to be 50 over here. Now the question states choose from the following downward payoff provided under a replicating call option. So again, the question is not actually clear, honestly, in my opinion, and also 3 marks devoted looks a bit high. So what I have assumed is that they are simply asking what shall be the payoff, in case the stock price moves down. So the exercise price is 50. We have a, let's say, we have a call or a put. Is it given the actual probability? There's a monthly binomial model in a 1 year. The compounded is, it's a call option only. Yeah. So your payoff will be either 50 when the stock price moves to 100, or it will be 0. That's it. I mean, because strike price is 50 and the current price is and the price at expiry will be 30 in one case, in the downward case. So your payoff will become 0. So it's option B. So again, you might think this should have been ideally of 1 mark, but then it's given of 3 marks. I spent some time just to think if I was missing out on anything or not. Doesn't seem so. Also, again, would just like to inform you all that in case of you identifying any sort of errors, calculation, or conceptual errors in this particular video, feel absolutely free to point those through the comment section. We'll definitely take a look at them, and in case we find merit in that, we would be pushing in the rectifications through the comment section. So all of you watching this video, do also or take a look at the comment section just to see in case any sort of rectifications have been pushed in. Then question number 5 we have, it's a very standard question, I'll say. Probability of ruin at the first claim in case of fixed amounts, and then it's option number 1 over here. You all can solve it and you'll get this particular thing. It's using the direct formula. Then part 2, again, this has been picked up. It's similar to what has been asked in the past year of IFOA, both part 2A as well as B. So this is the solution. It's a pretty detailed one, I'll say. These are the 4 possible cases for the surplus process at time 1. And we see that the ruin probability will be adding these 2 probabilities, which comes out to be 0.05. And then for part the next one, so this is year 1, this is year 2, no claim, no claim, no claim, no claim. Here it's no claim, A claims, B claims, both of them claim, so on. The respective probabilities I have written it over here. And then finally, you all could calculate this easily as well. This is nothing but the surplus amount. So one way is, you add up all the probabilities where surplus is negative. Alternatively, you could do 1 minus A minus C minus C. So I've used that approach. And also, ultimately what you can also comment is that here ruin shall occur the moment B claims, where, there's a payout, or not, sorry, B, it's actually A over here. Let me just check the question. Yes, if A makes a claim, then there will be ruin. So, right, so you can think that the probability of making a claim in the first year is 0.05. Doesn't matter what B does. A makes a claim is 0.05 plus in the second year 0.95 into 0.05. So 0.05 plus 0.95 into 0.05 will give us the answer as well. And that will give us same thing, 0.0975. So this was it. Then moving forward to question number 6. Part 1, state in words the four axioms of the expected utility theorem. Straight direct bookwork, So this time I'll say paper was extremely scoring because such direct questions have been asked. So, students who had, let's say, spent some time in remembering these assumptions or axioms, they should have, been in a position to write this down properly in a very less amount of time, and this should fetch high marks. Part 2, express his expectability of wealth in terms of A, and part 3, determine the amount. So again, this nothing difficult, fairly typical type of question we get from a utility theory question. So I have denoted the wealth, and this is the expression, and finally the utility. And in the next part, we need to differentiate with respect to A over here. And on solving this, what I'm getting is A to be 5 by 12. And this is the proportion invested. Therefore, the amount invested in A is 5 by 12 into 10 to the power 5, which is 1 lakh, which comes out to be 41,666.67. Then question number 7, explain one drawback of the Black-Scholes option pricing formula. So the model assumes that we have a constant volatility over the duration of the option. Although this might not be true, this might, change. Then you could also talk about assuming a constant dividend yield. Again, practically, for short period options, that is a fairly good approximation or a fairly good assumption. Similarly, if we talk about the risk-free rate of interest, we assume it to be constant. So if we're talking about, let's say, very short duration options, say 1 month or 2 months or less than that, that's a fairly good approximation. But for a very large duration options, that might not be the case. Like in the current environment, most of the central banks across the world have been increasing the interest rates, be it, let's say, talk about the Fed from US or even RBI from India. We are moving into an environment where the interest rates are expected to increase at least for the next couple of months. That is the expectation. So part 2, it's given certain details have been given. Part 2 is, calculate the price of the put option. We can use, let's say the put call parity over here. And using put call parity, I'm getting as 106.41. Then for part B, I need to basically find the price for put option with strike price of 5,500. So again, you have the equation, you need to use trial and error. What I used was, just to save time, I simply used options calculator. You get these online, wherein you can feed all the relevant data and you can calculate the implied volatility. So I was getting something to be 11.84%. So again, through trial and error, you might get 12%. Again, it depends, the range of values you're taking. If you're taking sigma as 10% and 20%, you might get a very different answer. If you're taking, let's say, 10% and 15%, then, you might get something around this. So the final answer will vary depending on, how far you have approximated. And, I have approximated till 2 decimal places, and this is more of an accurate answer. After applying linear interpolation through trial and error, the final answer which you'll get could be different. It could be, let's say, 11% or 13%, depends on the two values you're using. And then further, I have also, to save time, in exam, I would have, actually taken these values only D1 till 4 decimal places. But here, let's say, I've taken till 2 decimal places. If ever you're running short of time, always do that. And by putting this, I'm getting the value as 34.69. So two assumptions over here, you will say, or what I should say is different students might get the different estimate of sigma. And then depending on, how till what decimal places they use D1 and D2, the final answer might vary. So again, might consume a little bit of time and party, but nothing difficult, very straightforward. Question number 8, inflation is assumed to be between 3% to 11% each year. So therefore, the mean rate will be nothing but 7%. Uniform A is 3%, B is 11%. The mean of a uniform distribution is A plus B by 2, which comes out to be 7%. Then part 2 is, the mean inflation rate over 10 years, assuming independent yearly inflation. So it's every year, we are assuming on average to be 7%. So on 10 years, it will be 1.07 to the part 10. This becomes a total inflation factor. And if I subtract 1 from this, I'll get the total inflation rate. And that will be coming out as 97.32% part 2. Then for part 3, we need to find the variance of the accumulation. So if Y is the total accumulation due to inflation, okay. So 1 plus x1, inflation growth in first year, second year, so on, and then a -1, just to give the inflation rate, the overall inflation rate. So here you can think of, y as the accumulated inflation. If you talk about, let's say, the inflation factor, accumulated inflation factor, then it should have been actually 1 plus y over here. So it depends on how you're defining. End result should be the same. Xi is uniform 0.03, comma 0.11. And so I start with variance of y, which is variance of, this entire thing. One is a constant, I can remove it, it's this. Then variance x is nothing but expectation x square minus expectation x whole square. I expand 1 plus x whole square, and all of them are independent and identical. So this steps comes assuming that they all are independent and identical. And finally, I have this. So expectation x we did already have. For expectation x square, I can use the results for variance x from actuarial tables, and then I can calculate expectation x square. And using all this, I'm getting the variance to be 0.01806414015. Then for part 4, expected amount to be invested today to retain the purchasing power after 10 years. So basically, if I want a purchasing power of 1 today, right? Or let's say after 10 years I want of 1, uh, then assuming inflation, I mean that 1 will basically would have increased to 1.07 to the power 10, assuming that this mean rate is there. Also for part 4, this sort of detail has been given below. So ideally, if I look at the structure of the question, for part 4, this shouldn't be used unless, it's written that, use this following information. But other than that, there is no other way I could come up with to solve. So I have considered a split of 60% in equities and, 40% in fixed deposit, giving a risk-free return of 7% per annum. And then I've also assumed that the growth rate follows the log normal distribution with parameters 0.09 and zero point 0.2. So this is the solution for part 4. Xi is growth on equity. Xi follows log normal 0.09, comma 0.04, which is zero point 0.2 square. B I have defined as x1, x2, x10. So x1 is the growth. If I say that the growth is 20%, right? So basically your price will be what? Current price into 1.2. So the growth factor becomes, let's say, 1.2. So I'm not talking about the return, I'm talking about the growth. A 20% return translates into a growth of 1.2. So B, I've defined x1 into x2 into x10, across the 10 years, whatever returns you're getting on our equity. And we know that multiplication of independent log normal will give us a log normal distribution. So it's 10 into 0.09, comma 10 into 0.04, which becomes 0.4. Let's say if we are investing A, so 60% we're investing in equities. 0.6 is the amount invested in equity into B, the growth factor, plus 0.4A amount invested in fixed deposit into 1.07 to the power 10. Now expectation of this should be nothing but this 50 lakh, and then I have multiplied this with a factor of 1.07 to the power 10 to adjust for inflation, because we need the same purchasing power. On solving this, further you'll get A as 37,98,527.895. Want to round off to the nearest integer, it shall be 37,98,528. Part 3 again, we want the probability, that for this to, we achieve the required amount is 50%. So I can write in this way, the amount greater than the required amount is 0.5. Then I have, just put in all the other values apart from B over here. B is the random one. Then I have standardized it. So I have taken the log of B over here. And this entire term, if you'll see, I've just written this as C. This entire term in the brackets, I've written this as C, just to keep my calculations a bit short. Even in exam, this is what you're expected to do. If you do this, things will become very easy. Instead of writing this again and again, you just need to maybe write it once, denote as C, and then in the last step, you could, change it. So LNC minus 0.9 by root 0.4, which I need to equate to 0. So LNC comes out as 0.9, C comes out as a to the power 0.9. I replace the value of C over there. So, this is basically my C. And then rearranging, I'll get AS 43,47,060.625. And this is expected. It's a positively skewed distribution, log normal. Therefore, the mean value, if we're considering a mean value, our investments shall be less. But if we're looking for a median value, then we need to invest in higher amount, given it's positively skewed. So the probability of, let's getting smaller returns might be, they might be more frequent. You can think in that way. Or you can think it's positively skewed, so your mode comes first, then comes your median, then comes the mean. So mean will basically incorporate a higher rate, where a median will take a lower rate. So if I'm using the median, it means I'm assuming a lower rate, and that should mean that I should invest a higher amount to reach my goal. Then question number 9, part 1 and 2, policyholder behavior, how, it affects the risks and price, and then about the blockchain technology. This 2 marks, I will say, is, something where you need to apply, not directly from material as such, it's more about a general environment. And part 3, need to find the 99.5 VAR. So here's a look at the solution for same. And describe the random variable X, which is, let's say, the payoff or the profit for the insurance company, ignoring premiums, just the payoff, you could think. 0 minus 45 lakh, because its expected loss is 90% of 50 lakh, which becomes 45 lakh. So 0.99, 0.01, in this way I get the 99.5% VR as 45 lakh here. Then similarly for part B, these all values are coming from actuarial tables itself. Here is, 99.5% VR will be when N takes the value 2, which basically corresponds to loss amount of 90 lakh. Two claims into 45 lakh each will come out as 90 lakh. And then finally question 10, it's directly, so question number 10, part 1, A, B, I'll say direct book work. And for part 2, this question has already come. In fact, this was the question which had come when I was appearing for my paper. That is September 2017. I had appeared from both IAI and IFOA. So this question was there. And, you could take a look at it. Again, this question is tricky because, I will say there was an update to material post 2017 where they clarified how to go about with the procedure. We generally have a tendency, we'll find the CDF, and then for discrete, we'll again take the double summation, maybe think of it as CDF of CDF to compare. But that is only possible when the returns are given to be equidistant. Here, the returns are not equidistant. I mean, -5%, -3%. There's a distance of 2%. Then from -3 to 0, it's a distance of 3%. So directly using this, you cannot conclude, or at least on this, let's say, the second order, you can perform integration, but again, that is something which is not there in material. So a lot of students get confused with that. And the double summation is a more easy route, but you can only this if you can only do this if you modify it. And how you can modify it is, you can bring in -4%, -2%, -1%, 1 to 4%. All these will have probabilities of 0, fine. But then you bring on this and then you construct a table where the returns will be from -5% till 5% with a step of 1%. And then you can perform double summation. So honestly, I had got this question wrong during my attempt. I had scored something around, I guess, 83 or 84 out of 100 from IFOA. And I was actually hoping 90 plus or so, but then I realized, I lost a major chunk of marks in this particular question, because by that time, there was no such example in material nowhere. So even my understanding was, which a lot of you might have, is just simply perform double summation, but that is wrong. Post that, when I checked out the solution and later, there was a addition to the material as well, then I realized, okay, in this cases, this is the approach which needs to be used. So that is something, we now cover in our classes right from 2018 itself, so that students now exactly know how to go about it. So this is all we have in this particular video. Hope that all of you did find this video useful. Please do like and share it with all your friends so that it reaches to most of the students whom for whom this particular video might be helpful to make a decision on what papers they should start preparing for the next session. Thanks everyone.